Hey everybody, in today's video we will be building a regression model with Keras. Keras is great for beginners due to simplicity, and you will see that we can build a complex neural network with only a few lines of code. So in today's lecture, I don't really want to call it a lecture, but that's essentially what it is. We're going to start by downloading and cleaning the data set, then we're going to import Keras, then we're going to build a neural network, then we're going to train and test the network, and this is where the fun comes in. This is where you get to play around and experiment. So first what we're going to do is download and clean the data set. We're going to import pandas as PD, import numpy as NP. Then we're going to, this data set is about the compressive strength of different samples of concrete, and it's based on the cement, the blast furnace slag, the fly ash, water, superplasticizer, coarse aggregate, and fine aggregate. These are all things that we use to determine the compressive strength. So first what we're going to do is download the data set. I'll include a link to the data set in the description. So first what we're going to do is we're going to get that data, concrete data.head, which is going to show the first 5 elements. So we can see here we have the cement, we have the blast furnace slag, fly ash, water, superplasticizer, coarse aggregate, fine aggregate. We also have the age and the strength. So in total we have 8 predictors, and we have 1 output, which is the strength. So now what we're going to do is we're going to look at the shape of the data set, which is going to tell us how many data points we have. So concrete data.shape, and we run that. And what that does is it shows us that we have 1030 samples with 9 predictors, but it's not actually 9 predictors. This is 9 columns. So we have 8 predictors and 1 output. And so remember, this is how many rows we have, so this is how many data samples. Rows, columns, rows, columns. I'm going to continue to preach that throughout all my videos. Everything we do in NumPy that regards an array is going to be rows and columns, or any type of data set. It's going to tell you the rows and the columns. So remember, rows and columns. It's a very important thing in linear algebra, matrices, machine learning, deep learning, and everything going forward. So what we're going to do is we're going to look at the data set again. So we're going to make sure that there's no errors, no missing values, nothing. So we're going to run this, the isNull function, to check if there's any null values or not a number values. So we don't have any of that. So it looks like the data is clean and ready to be used to build our model. So what we're going to do is we're going to split our data into predictors and targets. So we have concrete data columns, and we have concrete data dot columns. And what we're going to do is predictors equals concrete data columns, and then you're going to take concrete data columns not equal to strength. So what this is going to do is it's going to index all the columns that are not the strength column, and there's 8 of them. So what that's going to do, now we create the target equals concrete data strength, so just the strength column. So we're going to run that. And then we're going to do a quick sanity check of the predictors and the target to make sure that our predictors are, in fact, our 8 predictors, and our target is indeed the strength column. So we can run this. And here we have the predictors using predictors.head. So you can see you have cement, blast furnace slag, fly ash, water, superplasticizer, coarse aggregate, fine aggregate, and the age. Next, what we're going to do is we're going to take target.head to see what the target looks like, and it should just be 5 values. And there we have it. It's 1 column, 5 values. Next, what we're going to do is we're going to normalize the data. This is a big thing in statistics, something you have to do in order to normalize the data set. That way we can actually use it inside of our neural network. So we're going to run this. We're going to normalize the data set. And what this does is it takes the predictors minus the mean of the predictors divided by the standard deviation of the predictors. And then this is what it returns. It returns values that are pretty similar to each other. So now we have the number of columns. So predictors underscore norm dot shape 1 is going to print the number of columns of the predictors. So we have 8 columns for the predictors. Next, this is where we start to have fun. We're going to import Keras. And when you do this, so if you run this Jupyter notebook on your own, you're going to have to make sure you install Keras. If you're using Anaconda, you use conda install tensorflow, and then conda install Keras. You have to have TensorFlow in order to install Keras because Keras is built on the TensorFlow library. So we're going to run Keras, and this is using the TensorFlow backend. See right there, it tells you that. So what we're going to do is from keras.models, we're going to import sequential, which is what allows us to build the neural network in sequence. And then we're going to, from keras.layers, import dense, which allows us to create each layer. Our input layer, our hidden layers, our output layer. So now we're actually going to build the neural network. So we're going to define our regression model as model equals sequential. So you have to put this in there. This is what allows you to build them in sequence. And then what you do is you add to that model. So dense is going to be our first layer, our first hidden layer, which is going to have 50 nodes. The activation function is going to be the ReLU function. Then the input shape is the number of columns. So the number of columns is 8. This allows you to put in your input layer. So what you do is, in order to add that first part of the model, you add the hidden layer and the input layer in one. So this input layer is 8 nodes because we have 8 columns. And then this one is 50 nodes. And then you add another hidden layer, which is 50 nodes, just to add a little bit more model complexity. And then you have your output layer for your model, and that's going to be 1. Any regression problem like this is going to have 1 output because we're only looking for 1 output value. We're only looking for the strength, the compressive strength in megapascals. So then we compile the model using an optimizer. We're using the Atom optimizer. And then our loss function is going to be the mean squared error, or MSE. And when we run this, we return the model. And here we're going to train and test the network. So we run it on predictor norm, the target, the validation split, which is, this is saying that the validation set is going to be 30% of our whole data set. And then epoch is the number of iterations. So we run this, and we should see the model doing its training and testing. So we run it. And as you can see, it's trained on 721 samples, and we validate on 309 samples. And this is what it's doing. It's running the test. And there we have it. So here we have the loss and the validation loss. And a key thing is that the validation loss should always be a little more than your loss, which will prevent overfitting. Versus, let's say we have a case where the validation split is like 0.05, and we run this. What's going to happen is when we get down to the end, the validation loss is going to be less than the actual loss from our testing set. So from our training set. So the loss on our training set is now greater than the validation loss on our testing set, which doesn't really make sense. This means our model is now overfit. So what you want to do is you want to make sure you have enough data in both the training set and the testing set that your values come out reasonable. So you could probably even get away with doing like 0.25, and you could run this and you'd still get a good model. So when you look at the last ending point, see, now you still have a pretty good model. Your loss function, and then your validation loss. These are just the error values that you get from the MSE function, the mean squared error. That was our loss function. So that's all we have for today. I recommend playing around with this. I'll leave a link to the Jupyter Notebook in the description, as well as a link to the dataset. So feel free to play around with this by increasing or decreasing the number of neurons. Add more hidden layers, increase the number of epochs, and we do all that in these two models. So in model.fit, you can play around with the validation split, the epochs, the model nodes, and how many layers. You can add a new layer just by copying these and doing another one. So play around with that, mess around with it, see what happens. You can also run TensorFlow off of your GPU if you want to speed things up. When you install TensorFlow, just install tensorflow-gpu instead of just TensorFlow. So that's all we have for today. Thanks for watching my video. Like the video if you liked it, dislike it if you disliked it. Please leave your comments below, and please consider subscribing. Thanks for watching.